first thing we will learn about what is charge density. I think this is it. So, depending on the pattern of charge distribution, we can have 3 types of charge density. Okay, so one is linear charge density. The second one is surface charge density. Third one is volume charge density. Simple way to remember. How will you remember this? It's very simple, like this is 1 dimension, only line. This is 2 dimension, like plane area. Okay, and this is 3 dimension. Okay, so what is the linear charge density is given by lambda. Surface charge density is given by sigma. And volume charge density is given by rho. All these symbols you must know. And these definitions are very simple. What is linear charge density? One by one we will see. So what is linear charge density? Density means what you have learned so far. It is mass by volume. It is nothing but what? Per unit length or per unit area, per unit volume. How much amount of charge is distributed over that? A small element. Over the small element, how much we are doing it. So how can we do that? This linear charge density is given by what? Here, the line charge density also you can say. So what is the definition if they ask? It is nothing but what? It is represent the linear charge density is given by charge per unit length. It is defined as the simple definition. Charge per unit length is nothing but linear charge definition density. If they ask you definition, this much is enough. And how to represent that? It is given by the symbol lambda. Charge per unit length. Here we calculate. See, this is a line conductor. Okay, and here the charge distribution is uniform. We have assumed. Okay, so here if I have to find out what is the density means, we are talking about a particular unitary method. Okay, so over the small element dl, how much is the charge distributed? Okay, this is the small element dl we consider. In that, what is the amount of charge present in it? Say for example, it is dq. Then what is linear charge density? It is nothing but dq by dl. The reason is we are assuming that the charge is uniformly distributed, so we consider a small element dl. And in that, how much amount of charge is present over there. So after that, what we will do? We will extend the length. Okay, from 0 to infinity. If the length is given AB, then we will use the entire length to integration. That we will see in the upcoming derivation. Is this clear now? Charge per unit length is nothing but the linear charge density. And what is the SI unit? From the formula you can tell me. Charge it is coulomb and for length it is meter. So coulomb per meter. Any doubt in this? It is not necessarily the dq by dl only we can use. Average, that is del q by del l also we can use. Clear? Both are fine. Now, the next one is what? Surface charge density. And here I forgot to give the examples. See, linear charge density, what we can have? A straight conductor line. And here the charges will be arranged uniformly. Correct? So there we can say that lambda. And what is that? A ring. It is a ring. Ring means a straight wire is bent in the form of circular ring. So how will be the charges arranged? You know that the charges will be arranged in the outer surface. So here we can have this. This is the linear charge distribution. Clear, ma? Single line charge. Next. So the next one is what? Surface. Just a minute. Is it a pen only, right? I think okay. Surface charge density. So what is surface charge density? As I said, here we talk about a plane. Okay. Say for example, instead of ring, if you take one circular disc inside also area is there, no? So in that, how will be the charge will be distributed on the outer surface only. There is no change in it, but it is a disk. So you are considering a two-dimensional figure. Okay. So here, if you talk about the surface charge density, it is given by the letter sigma. How will you write sigma? Sigma is charge per unit area, we say. So here we take it as dq by dA or del q by del A. It is not necessary A only you should use. You can use ds also. Clear, ma? So here again, what is the SI unit? From the formula, we can say that SI unit is charge, coulomb per meter square. For area, it is meter square, so coulomb per meter square. Is that clear now? So what is another example? It is a plain sheet if you consider. So in this plain sheet, the outer surface, the charges will be distributed like this. So now what is the surface charge density? If I ask you, you will simply say that, ma'am, it is nothing but dq by ds. If the surface area is yes, then you will give like. Clear or no? One more example, if you want surface charge distribution, hollow cylinder. Not solid cylinder, hollow cylinder. Okay. Here also, in the cylinder, over the surface, the charges will be distributed. So what is the sigma? You can write it as charge per unit area. Clear or no? The next one is, if it is not, let me know. The next one is volume charge density. So what is volume charge density? It is three-dimensional. Over the entire volume, it will happen. So how it can be? So it can, that is the symbol is given by rho, and it is given by charge per unit volume. Over the entire volume, charge has been distributed. So we can write it as del Q by del V or dQ by dV. What is the SI unit? Simple, it is cubic per coulomb per meter cube. But you may ask, in conducting sphere, what will happen? Sphere is the best example for this. But as you know, only the charges reside in a conductor. If it is a conducting sphere, the charges will only reside in the properties of electric field lines. I told you. Charges reside outside because of the force of repulsion. They don't like each other and they just go and sit on the outer surface. But here I am talking about uniform volume charge distribution. That means what? Here it should be an insulating, charged insulating sphere. And we have distributed the charges in such a way it is uniformly spread over the entire volume. Here, what is the symbol for it? Is it clear or no? All of you?
Yes, ma'am.
Good. Whenever you consider this, see, whenever we talk about surface charge density, linear charge density, the thing you have to remember is you have to consider the area vector.